All right. Good night, everyone. Good night, students.
Good
Good
night,
evening.
sir.
Good night, sir.
Good night. Good night. Good night. Hope everybody's doing well. And welcome back to another session, our second and last for the week. And we're going to jump right into what we're going to be discussing tonight. But of course, as usual, we usually start our session by doing a brief little recap in the event that there's anybody new that might be joining the class for the first time. Is there such person or persons? Do we have anybody who is new that may be joining for the first time? No one is new? Okay. All right, so all my usual students are present. All right. All right, so we're gonna jump right into it, guys. No announcements going forward. The only thing that I can tell you guys is that you to brace yourself for a small assignment that's coming up. I'll let you know like a week in advance, but it's most likely going to be sometime next week. The assignment would have to be submitted to the office, and then when it's marked, you guys can pick it up at a time that's convenient to you. Okay? But obviously, I'm not able to like test you online because of the I'm not sure how genuine the results are going to be, but I'm still going to be able to see how effective you are when you're given a paper and how you produce the results. All right. But I'm trusting that you're going to not cheat yourselves and give it your best shot. But I'll let you know, guys, when it's going to be administered. I guess it's going to be administered online, and then you're going to submit it to the office so I can mark it and give you back a true grade. All right. But that's the only thing I have coming up. No more announcements. Let's dive right on in. In our last class, if you were to pull up our notepad from the last session, I'll just give it a minute, let it load. All right. So from our last session, you can see that we were obviously having some sort of discussion as it relates to fraction. Unfortunately, guys, I was not able to record that session. Well, the session was being recorded by me, but I'm not sure where to find the actual video. Until I can locate it, then that session is pretty much in thin air. But I'm trusting that the session was effective and you guys got it. But as usual, we're going to go through a brief review of percentages. All right, you can see that that's what we were discussing, percentages. We looked at a couple different questions. We looked at questions involving mixed fractions. We looked at questions involving whole numbers. We looked at questions involving decimals. So we're going to be doing, well, our topic for tonight is going to be direct and indirect proportionality. All right, that's going to be the main topic. But we're going to use the opportunity to do a quick little recap on what was discussed last class. Okay, so let's jump right in. All right, just give me a second. Let me get a visible ink here. Hold on, give me a sec. All right. All right, here we go. So, given a question, let's say that you're asked to calculate 30% of. So you want to find what is 30% of just a random number, doesn't have to be anything specific. 30% of the $175. Okay. All right. And we're told that once we're given the percentage value, the percentage should always be divided by 100. And then we are going to then multiply it by the value of the quantity that we're trying to find, which is in this case 175. And you have an option. You can go ahead and use your usual cancellation technique. All right. If you want to do that, you can. You can just simply say this 0 will cancel this 0. And we can say 5 into 10 goes 2 times. And 5 into 75 will go, I believe, let me see here, 6 times. 6 times 25. That's no, 7 times. Okay, I think it's 7 times. 7 times 25. Let me see, 4 times 25 is 100. 6, right? 7 times. Okay, I believe it's 7 times. Okay, and then from here now, since 3 and 2 doesn't have anything in common, and 2 and 7 doesn't have anything in common, we can just simply say 3 times 7 is 21, and 21 divided by 2, that should give us a value of, hold on, no man, something wrong, guys. 2 into 10, so 5 into 10 goes 2 times, and 5 into 75. Somebody confirm that for me, please. 5 into 75 goes...
Sir, it's 175.
Yeah, 175, yeah.
Yes.
I can't 7 times. I was thinking that I was dividing it by 35. Pardon me?
35.
Yeah, man, that make more sense. 35 times. Right. Come here and say how we get 10.5. All right, beautiful. Let me lower this eraser here. Okay, good. All right, wonderful. Thank you very much, guys. And then now we have 3 multiplied by 35 is 105. And if we divide that by 2, then we should get a valid response here of $52.50. And that is 30% of 175. Okay. Now, again, as I said, you could have just avoided the whole cancellation and just simply type it on your calculator, and boom, you get your answer. Okay. All right. So we also looked at another example where in the event you're given the fractional form of the percentage. So it could be what is 15.75%. So what is 15.75% of, let's say, $1,200? All right. So what is 15.75% of $1,200? Just give me a second, guys. Let me check to see if anybody's in the waiting room. Let's see here. Is there anyone in the waiting room? Okay, there might be one person. All right, there we go. All right, back. So what is 15.75% of 1,200? We did in fact discuss that we could convert the 3/4 by typing 3 divided by 4 on your calculator. It would tell you that it is 15.75. So if you just want to resort to just using the machine to your aid, then 15.75 divided by 100, and we're going to multiply then that by 15.75 divided by 100 multiplied by 1,200. All right, and we could do basic cancellation here. 100 into itself 1 time, and 100 into 1,200 goes 12 times. Or just better yet, 2 zeros will cancel 2 zeros, so the answer remaining there is 12. And so by going on your calculator, guys, can you confirm that for me? What is 12 multiplied by 15? I believe it's about 184. Double check that for me, please.
180.
It's 184?
180.
No, it's 12 multiplied by 15.75.
184.8.
184 point?
0.8.
0.8. Somebody confirm that. The answer is sound off.
Sir, I got 189.
189, sir.
189. 189. All right, wonderful. All right, yeah, man. Mistake happens to the best of us, guys. No worries, no stress. All right, so it's 189. Yeah, man, that makes sense. Yeah, man, definitely 189. $189. Okay. Now, alternatively, like I said, math is not just work one way because these questions are they commonly appear on multiple choice papers. So you have to have a way to go around the question. Okay. So 15 and 3/4, you could simply go ahead and say 4 multiplied by 15, converting the mixed fraction to an improper. 4 multiplied by 15, that's going to give us 60. And 60 plus 3, that's going to give us 63. So as opposed to putting it over 100, we're just going to put it over the denominator times 100, which in this case is 400. We did discuss why it's going to be 400, but I'm going to recap that. So 4 times 15 is 60. 60 plus 3 is 63 over 4. But bear in mind that the 63 over 4 is just the conversion of the 15 and 3/4. Remember that percentage is out of 100. And then we're going to times that by 1200. Now, obviously, then you'll see here that the 4 is a denominator and the 100 is also a denominator. So by merging them together, you will find here that this becomes 63 over 400. And that's going to be multiplied by 1200. And so therefore, by canceling the 2 zeros here from the 400 and from the 1200, and then we can say 4 into itself 1 time and 4 into 12 3 times. When you multiply 63 times 3, you will find that you easily get an answer of 189. All right, so remember that the exam is set up in such a way that sometimes you will get sometimes you get the question where you're allowed to use the calculator, and there are also times when you may not be able to use the calculator. So it's good that you're efficient at both methods. But when I give you an assessment or you are given the option to use the calculator, then by all means you can do whatever you see best fit for you. Okay? All right. So that is most of what we really discussed in our last class. All right. So we're going to be moving on to a topic that is known as direct and indirect proportion. Is there anyone that needs to take off anything off the screen? Can you confirm if I can erase my screen?
Yes.
All right. All right, so I can erase my screen then. All right, beautiful. All right, so we're going to be looking at direct and indirect proportion. And again, we're still at the fundamental aspect of math, ladies and gentlemen. Please bear in mind that as we had discussed when you first met me, we are all trying to get everybody to have some sort of foundation.
Someone is seeking access to the class.
Somebody seeking access to the class. Okay, I guess that person is coming. Okay, so that's, oh, Damoy got kicked out. All right, I got you. Okay, thank you, Ken. All right, good. So now we're looking at direct and indirect proportion. And when I'm teaching this particular topic in my day school, in my day school and in my evening face-to-face classes, I always remind my students that remember that we're not start with the real maths yet, you know. We're not start with the real maths yet, but we're trying to get the fundamental aspect of maths because these little things are going to come up on a regular. These little techniques, these little fundamental concepts are going to come up. And so I don't want you to have any challenges. Pardon me, guys, my screen stopped sharing. So sorry. Okay. So I don't want you to have any challenges when it comes to the basic math when we reach deep, like into the deep waters. So we want to take some time and, work on these. So the principle that I'm going to be sharing with you tonight is a very fundamental concept, a fundamental aspect of doing calculation. So please head up for me, guys. As you know, I'm not going to write on the screen. I'm just going to dictate. our discussion, our topic of discussion tonight is going to be direct and indirect proportion. Okay? So we're going to discuss the direct aspect first. Ready? Everybody ready?
Yes, sir.
Gotcha. Let's go. Direct and, sorry, pardon me, guys. So sorry. Two quantities are directly proportional. Two quantities are directly proportional to each other. Two quantities are directly proportional to each other if when one quantity increases in value, if when one quantity increases in value, then the other quantity also increases in value. Repeating the information. Two quantities are directly proportional to each other if when one quantity increases in value, then the other quantity also increases. And the vice versa also is true. If one quantity decreases in value, then the other quantity also decreases in value. All right. So you can summarize that by saying vice versa. Okay. All right. So as one quantity goes up, the other one goes up as well. All right. Now, many times when I teach, there's several concepts in math, right? But I feel personally, and this is just my opinion, I feel like if a student is not able to visualize the math concept in real life, it's going to most likely be a challenge, or they're going to rely a lot on memorizing how the problem is supposed to be done. And we all know that when you memorize, it can easily leave your memory, right? Because it's not going to stay there for long. So if I can get you guys to have an understanding, a real life application of the concept, then I feel like it will stay with you longer. All right. And you'll have more of a chance of finding different ways of going around the problem. All right. So here is a real life application of the concept of direct proportion. Now, just agree with me. I know you're going to agree, but if anybody can just agree with me, okay? If it's true, have you ever walk into a store, or you walk into the market, or you walk into somewhere where they're selling more than one of the same items? All right. And as a customer, you want to buy more than one of the same item. But your very first question that you ask is, what is the cost of one of these items? Have you ever asked yourself that? Have you ever gone into a store and be like, in Jamaica, because obviously I don't know who is watching the recording, but you'd ask them like, how much for one of this item? How much for one of this blouse? How much for one of this water? How much for one of this apple? As a customer, right? A customer always seeks to find out what is the cost of one quantity. And the reason why a customer will ask how much for one quantity is that they are subconsciously calculating how much of that quantity can they purchase with the amount of money that they currently have. Now, a customer subconsciously knows that if, say, for example, I'm going to do a little bit of drawing here. It's not going to be the best drawing, all right? Let's just say that a customer wants to purchase a couple apples. Could be any amount, right? Customer wants to purchase a couple apples. Give me a second, guys. What's going on here? Okay. So let's say that a customer wants to purchase an apple, right?
Excuse me, sir. There's someone waiting to join.
Somebody wants to join. Okay, thank you very much. All right, hold on. Oh, there's a couple person that wants to join. All right, so that's my apple, guys. So a customer wants to purchase an apple, right? And they go into the store and they ask, what is the cost for an apple? And so the clerk, somebody's mic is unmuted, guys. Remember, keep your mics on mute. Keep your mic muted just in case there's any background noise. Okay. Remember, the session is being recorded. All right. So let's say that a customer wants to buy an apple, and the question that the customer asks is, how much for one of the apple? And so the cashier's response is, the apple cost $100, right? At this point, the customer can then calculate on his or her own what is the cost of 2 apples. Then 2 apples is going to cost, obviously, $200. And so, obviously, if the customer wants to buy 3 apples, then the customer knows that it's going to cost what? $300. And if it's possible that the customer wants to purchase a half of an apple, then if 1 apple is 100, then the customer knows that the cost of a half an apple is going to be $50. Now, what you'll notice here, and let me just grab a different color ink here. What you'll notice, guys, is that as the quantity of apple, well, I need to draw the arrow up instead, my bad. As the quantity of apple increases, notice that the price of the apples are also increasing. All right. And notice then also that as the apple decreases, for example, 1 apple costs 100, this apple decrease in size. So I want half of the apple, then obviously it's going to cost the customer half the amount of 1. All right. So direct proportion is something that you guys do every day subconsciously. Every time you ask yourself, how much for one of this? You're doing direct proportion. Now, just like when you go into the market and let's say you want to buy some ground provisions, you will find everyone asking how much a pound for yam, how much a pound for pumpkin, how much a pound for this, how much a pound for that. Why is a customer asking how much for a pound? Is because the customer is he or she is calculating the amount that they want to buy based on the amount that they have in their possession. So you're currently calculating a direct proportion problem. All right. So there you have it. That's a perfect example of direct proportion. Everybody clear?
Yes.
Yes, sir.
All right. So we all kind of get the intuitive understanding of what is direct proportion. But then it still circles back down to how do we actually set up the working out, Mr. Peart? When I get a question, how am I going to know that this question is a direct proportion question? And if I do figure out that it's a direct proportion question, what is the layout? How do I work it out? Guys, take down this very simple example, right? And I'm going to show you how you would do a workout for this, okay? Here's example number 1. I'm dictating, guys. A car travels, and these are some very basic examples just to bring across the concept. But direct proportionality, guys, spreads right across mathematics curriculum. So you're going to do it in trigonometry, you're going to do it in matrices equation, you're going to do it in algebra, you're going to do it in consumer arithmetic, you're going to do it in all different, you're going to be doing it subconscious, you're going to be doing it and not to realize that's what you're doing. Okay? All right. So a car travels. This is the question, guys. A car travels 210 kilometers. A car travels 210 kilometers. You can shorten the word kilometers and just write km, guys. Okay. A car travels 210 kilometers on 7 liters of petrol. On 7 liters of petrol. You can shorten the word liters and write common L. So a car travels 210 kilometers on 7 liters of petrol. Full stop. Here's the question. How far would the car be able to travel? How far would the car be able to travel? How far will the car be able to travel? On 11 liters of petrol. On 11 liters of petrol. Repeating for the person who might have missed out something. A car travels 210 kilometers on 7 liters of petrol, full stop. How far would the car be able to travel on 11 liters of petrol? All right.
When is waiting
Now,
to join again?
pardon me?
Got kicked
I
out,
mean-
it's waiting to rejoin.
Okay, I've been letting them in, but I'm not sure what is happening. Because see that it says, I've been trying to let him in, so I'm not sure if something is wrong with his device or maybe he's using data and data is not going to allow you to stay in the class. It's going to kick you out every second. All right, he's in now. Keanu? 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 All right, guys, if you're using data, you might have some issues staying in the class, okay? To stay in the online class, you're going to require Wi-Fi connection to be consistent. But anyways, let's jump into it. All right, so to solve a problem like this, students, you always start off by writing down the information that is known to you in the question. And based on the question, whether it's true or false, you write down whatever was stated in the question. And the first thing that was stated in the question was that, pardon me, let me just, okay, hold on, give me a sec, guys. Okay. All right, so what was stated in the question is that, 7 liters of petrol will allow the car to travel a distance of 210 kilometers. So notice what I did? I write down an equation. And I've equated the amount of petrol it takes to travel that specific distance. Now, using back the understanding that we looked at earlier, where why is it that you always ask how much for a pound of this or how much for one of that, is the same procedure here. If you know that 7 will take you a distance of 210, your task is to find out how much or how far would you be able to travel on 1 liter of petrol. The moment you're able to calculate 1 liter and how far, you'll be able to calculate however many liters there is. So 1 liter is going to be equal to the number on the right. Always, this is the formula. The number on the right, which is 210, divided by the number on the left, which is going to be 7. And that is always the formula. Always the number on the right divided by the number on the left when it's direct proportion. Now, 1 liter is going to take us 30 kilometers. So 1 liter of petrol will take us a very short distance, and it makes sense. More gas, more petrol, longer distance. Less gas, less distance. Now, since as 1 liter takes you a distance of 30, and you now currently have 11 liters of petrol, then it will take you 11 times the distance of 1. That is 11 times 30, and you will find that you're able to travel a distance of 330 kilometers. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So I increase the amount of petrol that I have in my vehicle. That means I'll be able to travel a farther distance than 210. All right. Now, in real life, nobody actually does this. All right. This is just us showing you the math behind the subconscious calculations that you guys do. For example, I'm sure that there are students in here that has driven before or them drive a vehicle. So normally when you know that you're going a far distance, you normally put more than what you think you need so that you don't run out. So if let's say you're going to Kingston, right? And you know that on a regular basis based on the vehicle that you are driving, okay? Let's say you're going to Kingston, right? And you know that if I put $5,000 in my vehicle, I'll be able to go to Kingston and come back to Mandeville safely. But let's say that you wanted to go to St. Thomas, which is another parish adjacent to Kingston. You know, you're going to need more than $5,000 petrol. So the more petrol you placed in the vehicle is the farther distance you'll be able to travel. Hence, vice versa, if you put less petrol into the vehicle, is the less distance you'll be able to travel. And so that is the calculation behind it for direct proportion. Is it clear? Everybody clear?
Yes, sir.
All right, I want you guys to give this one a try. I just want to see if you guys get the setup of the calculation. Try this one for me. Sorry, guys. All right, ready for me, guys?
Yes, sir.
Yeah.
Yes, sir.
5 kilogram. 5 kilogram. You can shorten kilogram and write kg, please. 5 kilogram of peas. 5 kilograms of peas cost $17.91. That is 17.91. 5 kilograms of peas cost $17.91.
Sir, can you repeat that one more time, please?
5 kilograms of peas cost $17.91. That is 17.91. What would be the cost? What would be the cost if a customer wants to purchase 9 kilograms of peas? What would be the cost if a customer wants to buy 9 kilograms of peas? Should take you a few minutes to get to the answer. So go ahead, guys, give it a shot. Remember, keep your mics on mute if you're not speaking or asking a question.
Wants to buy
9 kilograms of peas. 9 kilograms of peas. Would anybody like to participate in discussing your layout?
Sir, me get 32.22
I want the
for
process.
answer.
I don't want the answer. I want you to, guide the students in what you wrote down, how you laid it out.
All right, so 5 kg equals 17.91. However, me have to find 1 kilogram first. So me say 1 kilogram equal to 17.91 divided by 5. Move further, we say 1 kilogram. After you divide it, you're supposed to get 3.58. And then we say 9 kilogram times 3.58 equal 32.22.
Well done, Mr. Larman. How much did they get? 32 point?
22.
All right, well done, Mr. Larman. Good job. All right, everybody got that answer?
Yes, sir.
Yes, sir.
Good job. Another question, but I want
Hold
somebody
on,
else to
sir. I
do.
got another answer. I got
Yes.
32.4, probably because I rounded off the 3.58 to 3.6 because
That's more than
5
okay.
is greater than the 6 and I put at the 1.
That is fine. So you'd still get the answer correct. Understand that whenever we are marking, whenever we get questions where we are dealing with figures of decimal places, as a marker, we mark, well, at least for me, when I'm marking, I mark for an answer within a range. So I don't mark for something specific. So if your answer is close to the answer when you didn't round off, you'll still get full marks. Well, at least for me when I'm marking.
Okay.
So you're still correct.
So
All right,
what
so another question.
was?
Pardon me there.
What did they say the answer was?
Oh, it's on the screen, love.
Oh, okay. Thank you.
You're welcome. All right, so another question for somebody else to try, to participate, to give yourself that confidence. If 26 articles cost $214.50, that is 50 cents. If 26 articles cost $214.50, what would be the cost? What would be the cost of 15 similar articles? What would be the cost of 15 similar articles?
Sorry that for me, I did kind of cut out for the first part of the question.
Do you need me to repeat?
Yes, yes.
If 26 articles cost $214.50, what would be the cost of 15 similar articles? All right, somebody else would like to participate? Someone would like to participate?
No, you need to.
Let me try, sir.
Sure, appreciate that.
Okay, so I have one ART, short form for article, equal to
One,
100
we started with one ART.
right.
So where is the setup for the original? What was the, okay, all right, let me just write what you get. All right, okay, so one, okay, no problem. All right, so one ART, is equal to?
$114.50 divided by 26.
Okay, I got you. Okay, so you just skip out the whole right back what they gave you. No problem. That's fine. That's
So
fine. That's perfect.
one art again equal 8.
0.26.
And
8
then
points? 8 points how much?
I did not say 8 point. I said one article equal 8.
$8?
Yes.
Okay.
And then I have
So it's
then
in
15 article.
Exactly 8.26.
8.25.
8.25.
All right. Just allow her to double check the 214.50 divided by 26 and double confirm for me, my friend. Double confirm if it's 8 or 8.25. It happens to the best of us now, guys. Because you could perhaps left off the 0 or left off the 5 by accident. It's fine. So just confirm if you get 8.25.
Oh, we have to do the decimal.
Yeah, man, you have to, because this is money that we're dealing with, okay?
Sir, may I do it to one figure?
Oh yeah, I got you. Okay. All right, so now you get 8.25 then. Since we know you're gonna check it, somebody else can wrap it up for her.
Yes.
Therefore what?
Okay.
Therefore, somebody else can wrap it up for her.
Okay, sir. So if one article costs $8.25, therefore 15 articles would be 15 times 8.25. It would give $123.75.
153 point?
123.75.
Oh, pardon me. 0.75. Thank you. All right, good job. Somebody have a question?
No.
Okay. All right, so it's 123. The handwriting is not so wonderful, guys. Let me just try to write it better. 123.75. All right, good job. So you get the idea. That is direct proportion. And that's always going to be the setup. Okay?
That many do I know calculator. That calculator give me wrong answer.
Guys, keep your mics on mute. Remember that the class is being recorded, okay? And just double check. I don't think the calculator is giving wrong answer. I think you just need to perhaps take your time and press the buttons. Just do it slowly and just make sure you get it, because it can't give you a wrong answer. Unless you're mistakenly putting 26 divided by 214.50. Remember, it's the big number at the top divided by the bottom number. Okay? All right, good. So that basically brings us to the end of direct proportion. All right. And there's going to be many applications that you're going to see with this concept coming in future classes. Okay. So don't forget that concept of writing down what you know, dividing the right by the left, and finding the value of 1. And for you find the value of 1, I always tell my student, the game is over. The moment you find 1, the game is over. All right. All right. Let's head up. Let's look at indirect proportion, which is the complete opposite of what we were doing. But we want to see how this calculation is laid out as well. Okay. Head up. So take this information from me, guys. Two quantities are indirectly proportional. Two quantities are indirectly proportional to each other two quantities are indirectly proportional to each other if when one quantity increases, then the other quantity will decrease. All right, so just repeating for you guys. Two quantities are indirectly proportional to each other if when one quantity increases, then the other quantity will decrease, and the vice versa occur. If one quantity decreases, then the other one will increase. And once again, as discussed when we were talking about direct proportion, unless these math concepts are aligned with something realistic, like, sir, the question that a lot of students ask me when I'm teaching, and this is something that I've now been attaching to my style of teaching, my way of getting across the concepts to students. I'm trying to find every topic that I teach, I try to find a realistic application of the concept so that it makes more sense to you. At least doing it makes more sense. And it's not just something that you're going to copy and try to remember. It's just something that you see every day. Now, indirect proportion is something that actually occurs when you're working with more than one people, when you and somebody else or you and a group of persons have to complete a particular task, right? Now, a perfect example of this is when you go into a public place and you are the customer, or there's a group of customers, and you have to be attended by a cashier. Now, I'm sure that you guys have gone into KFC or Burger King, or you've gone into the supermarket, and when you're going there and it's very crowded, your first request to the manager is, you all need to get more cashiers. Now, why is it that you think you're asking for more cashiers? Watch the arrows that I'm going to be drawing on the screen. You're asking for more cashiers because if you have, let's say we have a certain amount of customers, put them in this circle right here. So these dots that I'm drawing on screen here are all customers, right? And we have, let's say we have 5 cashiers. Oops, pardon me, guys. Let's say we have 5 cashiers, okay? Cash is for cashiers, okay? So let's say we have 5 cashiers that serves a certain amount of customers. Let's say that all these customers will be served in, say, 3 hours. All right, everybody will get through and everybody get to go home and everybody happy. All right. Now, what you'll notice here, and let me just use my red arrow just to make certain that you get a good visual. All right. Now, what is going to happen, guys, is these customers are going to say, why don't you get more cashiers? Because what's going to happen now, watch the arrows now. If you increase, if you increase the amount of, if you increase the amount of servers, then the time taken for you to get through is going to decrease. Does that make sense?
Yes, sir. Yes, sir.
That makes sense, right?
Yes, sir.
That means the quantity of servers has increased, therefore the time taken to be served is going to decrease. And the vice versa happens then, that if you were to have a shortage of staff, let's say from 5 cashiers, you only have 2 cashiers serving, then you're going to find that the time taken for these customers in that circle to get through is going to what? Increase. Does that make sense to you then?
Yes, sir. Yes.
So do you understand then, guys, that every day when you're doing your daily business, you're either encountering with a direct proportion or you're encountering indirect proportion. It is just now that you're realizing that, oh, so that is direct proportion. And then you're like, oh, okay, so that is indirect proportion. So when you're a customer and you hear somebody ball out in the line. Y'all need to get more workers, more workers. What they want is that they want to get through faster. So they're asking for an increase in servers so that they can decrease their waiting time. Does it make sense then?
Yes, sir.
Yes,
All
sir.
right, fantastic. So now that we have an intuitive understanding of indirect proportion, it is now time. It's now time to apply to the calculation. Please take this question down for me, guys. Twelve employees can complete a task. 12 employees can complete a task in 5 hours. In 5 hours. 12 employees can complete a task in 5 hours. How long would it take? How long would it take 7 employees? How long would it take 7 employees to complete the same task? How long would it take 7 employees to complete the same task? Now, one important fact here, guys, is that the task at hand is irrelevant to the calculation. That's why we say a task. So it doesn't matter how big or how small the task is. This particular task will require 12 employees and it will take, what me say, 5 hours or 3, what me did say? 12 employees will complete a task in what?
5 hours.
5 hours, thank you. In 5 hours. All right. Now, what you notice there is that the number of employees was decreased to 7. So what do you think is going to happen to the time for the task to complete? Is it going to go up or go down?
Up.
It has to go up. It's going to take longer. So there you can see that there's a opposite movement in the arrows. So we start off with saying that 12. Oops, pardon me. I don't think the red is working quite well. All right, good. So we start out by saying 12 employees. Guys, keep your mics on mute. Please always double check if your mic is unmuted. 12 employees will complete whatever this task is in 5 hours. Not true? So I need to calculate what happens if it was 1 employee doing this task. Remember the root of this problem here. The root of this problem is always you having the ability to find one share, one amount, one value. Always you have to find one. Here's where the reasoning comes in. Direct and indirect proportion are so close that so many students at times get it confused. What do you think I'm going to do here? 1 employee will take, is it 5 divided by 12 or 5 times 12?
5 times 12.
Very good. 5 times 12. Everybody in agreement? Is everybody in agreement? Do we understand why we have to multiply for the 1 employee and not divide? I'm assuming that silence means you don't want.
Please.
All right, so let's reason out the question then. 12 employees will take 5 hours. Put yourself in the position. Okay, your job that you have right now, 12 of you guys do your task, and in 5 hours, that task is completed within 5 hours, right? Suppose I did you alone at work. What would happen if you alone at work and you had to do everybody else's job?
The time
Could you have
go.
completed the task in 5 hours or more hours? You'd need more time.
More.
Would you
More
need more time or less time?
More.
More time.
So what does more mean? Does more mean to multiply or does more mean to divide?
Multiply.
Multiply.
So there you have your answer. That is why we're multiplying. Because the less employee you have, the less workers you have, is the more time is going to require to complete the task. Do we understand?
Yes, sir.
So therefore, one employee is going to take 60 hours to complete the whole entire task by themselves. Now, since I know that one employee will take 60 hours, how much employees are currently employed? Based on the question, how much employees was hired?
12.
No, that was before.
7.
7 employees is now
7.
hired, right? So we decrease the amount of employees, not true? That means the time. So we decrease the amount of employees, that means the time is going to take longer. So therefore, it's going to be what now? 7 employees. 7 employees is going to be equal to 60 divided by 7. Talk to me. It's going to give you an approximate answer.
8.
8 point something.
8.5.
8.5?
8.8 if you round it out. 8.57.
We hear 8.57. That's what I'm hearing.
Yes, sir. But
Okay, but when you run traffic at 8.6.
yeah.
8.6.
8.6. I think somebody's mic. Is it Damoy? I'm assuming that Latisha is the one that's talking to me.
Yes, sir.
All right, good. All right, Damoy, I think your mic is always unmuted, so try to make sure that your mic is muted, Damoy. And Sonia's in the waiting room. How long I'm not even saying anything. Anyways, I said it's approximately 8. So do you notice that we started with 12 employees, not true? 12 employees took 5 hours. We decreased the amount of employees to 7. Notice that the time has increased to 8.6. So there you can see a clear indication of indirect proportion taking place. Now the trouble in my years of teaching fundamental math, the trouble in this question is never the math. It's never what should I multiply or divide by. For me, the issue with this problem is the reasoning. Students are unable to interpret and understand when direct proportion is taking place versus when it's not taking place. So you guys have to, the only way you can fix that, well, at least the only way I think you can fix that is by you doing questions of similar nature again and again and again. You're going to develop a feel, you're going to develop an understanding. It's going to become automatic for you to read a question and be like, okay, this is definitely indirect. And by indirect, you know when to multiply or when to divide by through practicing. Okay? That's the only way to go stick. But let us see if you can take on one of these questions on your own. All right? This is your question, guys. A rice farmer employed 15 men to harvest his crop. A rice farmer employed 15 men to harvest his crop or crops. It took 12 days to complete the task. It took 12 days to complete the task. Everybody get that?
Yes, sir.
If he had hired 3 men less, if he had hired 3 men less, pardon me, sorry, if he had hired 6 men less, if he had hired 6 men less, how long would it have taken them? How long would it have taken them? Your reasoning ability is being targeted at the moment.
Could you please repeat? Your audio wasn't clear.
From the beginning? From where specifically, Ms. Kian?
From the first full stop.
Let's start from the beginning then. A rice farmer employed 15 men to harvest his crops. The men took 12 days to complete the task. Are you at that point?
Yes.
If he had hired 6 men less, how long would it have taken them? How long would it have taken them? Your reasoning ability is being targeted, students. Not your math, your reasoning. Let's see how you do that one.
Finish, sir.
Hold the answer. I'll give him a chance, you know?
Finish, sir.
Good job. Hold the answer. All right, so the student who said that you're finished first, do you want to walk your classmates through your procedure?
Sir.
Yes, go ahead.
For the 50 employer, for the 15 men, sir, at equal 12 days.
Okay, so 15. Give me a sec. Let me just write as you're talking. Okay, so you just tell me what you've written on your paper. Just read it out to me as you're going along. 15. So you write 15 employees
Equal 12 days. No.
Good.
Yeah. 1 employee equal 15 times 12.
Excellent.
Equal 180.
Correct.
6,
Therefore,
6 employees.
I disagree with you.
Sir, since I said it is 6 days less, 6 men less, you would subtract the 15 from the 6 and you'll get 9.
Very good. That's our catch. So tell us your reason on the attack. I didn't say if, I remember the question didn't say, if 6 men were hired. It said 6 men less. So initially it was 15 employees. And if he had hired 6 men less, then it would have been 15 minus 6. Should have been 9. So therefore, 9 employees would have been equal to 180 divided by 9.
Which you would get 20, so that would be equal to 20 days.
Correct. Anybody, did you guys catch that? Did you catch the trick in the question there?
Yes, sir.
Yeah. So the student that was talking first, just make a note of that. Remember that the English language, when they word the question, they will word it in such a way to mislead you. You have to be able to catch, see where they're trying to mislead you. Okay. So 6 men less is different from hiring 6 men. Okay. So just make a note of that. It's okay. We all make errors. That's how we learn it. All right. I am going to give you another question to try. A factory employs 18 women. A factory employs 18 women to sew 500. Pardon me?
Can you repeat, please?
Yeah, I was going to repeat it now. A factory employs 18 women to sew 540 dresses. Full stop. The women took 6 weeks to complete the task. The women took 6 weeks to complete the task. If 12 women were employed instead, how many weeks would it have taken them? How many weeks would it have taken them? Go ahead, guys. I'll put an extra number in that question to see if what you're going to do with it.
Suit me one more.
Guys, keep your mics on mute. Remember, this class is being recorded. Anybody wants to participate in this one? This last question here? That brings us to the end of tonight's session. Remember, guys, you can't be afraid to get something incorrect. You know, that's how you're going to know what not to do the next time. Say, man, just brave up, man. I don't want the same person, you know. I want somebody else.
Not the same person.
Okay, good. All right, talk to me.
Okay, so I started with by breaking down the weeks into days.
Ooh,
So
you've gone too far. The question is not that complicated. Yeah, that's a bit too much.
if
Because, yeah.
18 women took 6 weeks.
Pardon me?
18 women took 6 weeks. One
So
woman.
18 women. Give me a sec. Let me just write as you're going along. Hold on. Give me a sec. So 18 women took
6 weeks.
Took 6 weeks.
One woman would take
So one woman.
108 weeks. Would
108 meaning so you multiply the 6 by 18. Okay, good. So that's how much you say?
108.
108 weeks. All right, good.
They're trying to figure out how many 12 women would weeks 12 women would have taken. You would have say 108 divided by the 12.
Excellent.
And that would be 9 weeks.
108 divided by 12, that would be equal to 9 weeks. Fantastic job. Good job, guys. Good job. All right. And that is what we refer to as direct and indirect proportion. Now, we're going to be looking at this topic again, but it's going to be under the concept of algebra, where them call it direct and indirect variation. So it's going to come off with, I'm going to teach you this concept once again, but it's going to have a different feel to it. We're going to be using more letters than words, right? So don't forget the concept of indirect. When you hear indirect and direct again, just know that is going to be applied in a similar sense. Pardon me?
About this question.
Go ahead.
I'm a bit lost with the 540 and the
540 was a distraction because that was just the task.
Okay, so it's we're just focusing on the 18 and the 6.
That was a trick in the question. That's why I added that extra number to see if you were going to interfere with it. The 540 dress could have been 1,000 dress, 10,000 dress, 1 dress, 10 dress. It was a distraction. So I was hoping to catch you, but I didn't. All right, but good question though. Good question. All right, so that brings us to the end. So the topic that's coming up next, that is also going to be related to this, is ratio and proportion. Okay, that's going to be a really nice topic as well. You're going to be seeing quite a few direct and indirect proportion occurring in there. We're going to be looking at some really, somewhat of a tricky question. We're going to be mixing percentages with direct proportion. It's going to be an interesting topic. All right, it's a topic that a lot of people, for some reason, I find that quite a few students have expressed that they don't like. But with the 3-step process that I'm going to show you when it comes to direct ratio and proportion, you will find this topic quite comfortable when it comes to getting to your solutions. All right, so good advice, guys. I want to hope you have a good weekend and ensure that you guys get some good rest, because you can't function in math class without getting good rest. Okay, So have yourself a good weekend. Be safe, everybody, and I'll see you in the next session.
Thank you and same to you, sir.
Good night, guys.
Good night.